Okay, let's give you guys some more practice. So establish if this integral is going to converge or if it's going to diverge from 0 to infinity. Yeah, so press pause and have a go. Okay, so remember, dead on zero, this whole thing here breaks down. So dead on zero breaks down, and you're going all the way to infinity. So you're going to need to break this up into two separate integrals. So you're going to need to break this up into two separate integrals. One, one from 0 to 1, so one from 0 to 1, and the other integral being from 1 all the way to infinity, 1 all the way to infinity. So let's just randomly look at this one. Let's just randomly look at this one here. So now we need to establish if this is going to converge or if it's going to diverge. So the trick here is to compare this with this. If so here we are now just looking at this. Later on we will look at this. So forget about this for the time being. Let's just concentrate on this. Here you've got x here, and then you're going to times x squared here. So you can factor out the x. So factor out the x. So that will leave you with this. And then here you instead of x squared, you're just going to have x here. So basically factor out the x here. That will then give you this. And then in the region of 0 to 1, let's just look at this here. In the region of 0 to 1, y equals e to the power of x. So hang on, 1 would be here, and this thing here would be e, and this thing here would be 1, not to scale. So this is your e to the power of x. In the region of 0 to 1, in this region here from 0 to 1, in this region here, this thing here is always going to be less than or equal to e. It's always going to be less than or equal to e. So this thing here, we can compare it with this thing. So in this region from 0 to 1, this thing here will always be less than or equal to this e here, to the constant e. So now let's look at this thing here. Let's look at this thing here. Y equals x looks like this. So this is 1, and this is also 1. So this is y equals x. So looking at this thing here, in this region from 0 to 1, you can see that this thing here is always going to be less than or equal to 1, because the highest value is 1. So in this region 0 to 1, we can say that the maximum value is 1. So we can compare this with this, and then this thing here, we can compare it to the constant e. So this, hang on. So this thing here is always going to be bigger or equal to this thing here. So the denominator here, the whole denominator here would be bigger or equal to this whole denominator here. So if this denominator here is bigger, then it makes the overall thing here smaller than this thing here. So the point here is that this thing here will always be smaller or equal to this whole thing here. Okay, so now e and the 1 here, they're constant, so you can factor them out. So this thing here can become this. So now we've seen this many times here. You should ingrain this in your mind. Your 1 over x looks like this. 1. So 1 over x squared will look something like this. But then square root 1 over square root of x will look something like this. But here you've got 1 over x. So 1 over x in the region of 0 to 1, this is going to diverge. We've seen this many times, and you should have this ingrained in your mind. This thing here is going to diverge. If this thing here diverge, you times a constant, then it's going to still diverge. So something smaller diverge. So you've got this thing here. Hang on. 1 over x looks like this. In the region of in this region here, it's going to diverge. But here you've got something bigger than this thing here. This thing here is going to be bigger. I don't know what it looks like. I'm just going to guess it to be something like this. I don't care what happens over here. But this thing here is bigger than this thing here. The smaller thing here diverge. So therefore the big thing will have no choice but to also to diverge. So this thing here, the big thing here will have no choice but also to diverge. This thing here diverges. So this is bigger or equal to, it will have no choice but to have to diverge. So looking at this here, so remember we were trying to evaluate this here. We broke it up into two different integrals, one from 0 to 1, 0 to 1, and the other. Well, the point is that this thing is going to diverge. So let's not bother evaluating this. If this thing here is going to diverge, then the whole thing here is going to diverge, meaning this thing here is going to diverge, meaning this area from 0 to infinity is just going to get bigger and bigger and bigger. Okay, so yeah, so it's going to diverge.